All right, 22. This looks like another of those Poisson problems. um, Hits to a website occur at a rate of 9 per minute. Between 7 and 10, the random variable x is the number of hits. Between 9:33 and 9:43, we're going to state the value of lambda and t. So in the earlier problem I did, I told you lambda was the mean. And I went back and looked. This text is not using lambda as the mean. It's using lambda as the rate and then multiplying it times t to get the mean. So when we're doing 9 per minute, that's what they want you to say is lambda. So lambda is your rate. And then t is the time. So between 9:33 and 43 is 10 minutes. Now what I did before is I just multiplied this times this to get lambda, which in another textbook that's referred to as the mean. This textbook is saying continue to use mu as the mean and just let mu be lambda times t. Okay, but it still works out just to change a variable there. So we're going to put 9 here and 10 here. 23. Engineer wants to determine how the weight of a gas-powered car affects the mileage. The accompanying table represents the weights of various domestic cars. Complete A through D. So we're going to find the least squares regression line, treating weight as explanatory. So that's already in the X category. So I'm going to copy this to Excel. Editing. I can close this other one. I don't need that anymore. Alright, I'm going to highlight, insert, scatter plot. I'm going to do trend line, more options, equation, and R squared. Okay, so I got everything I need. The least squares regression line is going to be negative 0.0071. We want to round to 5 decimal places. So remember how we found more decimal places? We're going to go to more options. Let's get this both on there. Okay, so once this is up, not take options, general, here we go, number, and we want to show 5 places. Okay, so now we got 5 places. So what did I do from that options? We had to go back up to label options here. So 5 decimal places, 00712, negative. The constant, we want to round the constant to 1 decimal place. So this one is going to be 43.88. The 8 is going to round up to a 9, so 43.9. Interpret the slope. So we are looking at weight of a car and the gas mileage. So X is the weight. So as the weight decreases by, what are we counting? Is this in pounds? Yeah, pounds. As the weight of a car decreases by this many pounds, the gas mileage is expected to, no, as the weight increases by 1 gas mileage is expected to go down by this amount. So for every pound added to the weight, gas mileage will decrease. Yes. Every pound added to the weight goes up. We're going to decrease by the slope, negative 0.00712. A weightless car will get blank. So it doesn't make sense to say a weightless car, you won't have a car. There's no car that doesn't have weight, so that's not going to be the one. Every pound added will decrease by this. It is not appropriate to interpret the y-intercept. There we go. So negative 0.00712. This is the one we want to use. C, a certain gas-powered car weighs 3621, gets 16 miles. Is the miles per gallon of this car above average or below average of its cars? So we look at our data. We don't have a 3621. Okay, they're just saying that that is the case. So based on our model, we want to know, is this above or below? So I'm just going to plug in 3621 for X and see what happens when I compute that. So turn this on, 3621 times that slope of negative 0.00712 plus the y-intercept, which is 43.9 when we round it, 43.9. So just plug in that value. So that car, according to our model, would get 18. So the fact that this is getting 16 is below the average. So the estimated average miles per gallon for a car of this weight is, and we want to round to 3 decimal places, so we got 18.118. I don't know if we just want to say 18. The miles per gallon of this car is below average for cars of this weight. The estimated average is this. The miles per gallon for this car, this one right here, 16 is below 3 decimal places as needed, so yes. Okay, so would it be reasonable to use least squares regression line to predict the miles per gallon of a hybrid gas and electric car? Why not? So not with this model, because this model is only gas powered. So the data would be very different with a hybrid or electric. So no different type of car, that looks good. No absolute value, less, yes, yes. So no, because that's a different type of car.